Hello my dear students, I warmly welcome you to CR Digital Classes. Okay, so in this lecture, we are going to discuss about a problem based on the Newton Raphson method. Okay, so in the previous lecture, we discussed that the Newton Raphson problem theorem only. So now, see the problem based on the Newton Raphson method. Find the root of equation x sin x plus cos x is equal to 0 by using Newton Raphson method. Okay, so given equation is a trigonometric equation x sin x plus cos x. Okay, algebra and trigonometric. Okay, you can also call it as a transcendental equation. Okay, in that algebraic function x is the algebraic function and sin x cos x are the trigonometric functions. It is a transcendental equation of linear order. Okay, linear order is 1. Okay, so in one variable, in single variable. So therefore now we have to find out a real root for this equation by using the Newton Raphson method. See that, okay, given equation is x sin x plus cos x is equal to 0. Now we have to convert this given equation into tangents. Okay, so therefore to convert that one, so divide on both side with cos x. Okay, for the given equation, divide on both side with cos x. So therefore if you divide with cos x, then you will get x sin x by cos x plus cos x by cos x is equal to 0. So therefore you know very well sin x by cos x is equal to tan x. Okay, and cos by cos will get cancelled, then you will get plus 1 is equal to 0. X into tan x plus 1 is equal to 0. Okay, so given equation we converted into tans, so that is also a transcendental equation. So therefore f of x is equal to x tan x plus 1 is equal to 0 is the given equation. Now to apply the Newton Raphson method, so what is the formula for the Newton Raphson method? So this one is the general approximation formula. Okay, so if you observe carefully, f of x suffix I is there, f dash of x suffix I is also there. That means for the given function whatever you get, so you have to take the derivative of that function also. In that derivative you have to substitute the first initial approximation value. Okay, so that is the general formula for the ith iteration for the Newton Raphson method. So therefore f of x we got, it is equation number 1. Now you have to take the derivative for that equation f dash of x. Okay, so if you apply the derivative, you can apply u into method. You can take it is a v, tan x as v. So therefore u into v dash, x is the u into v dash. V dash means tan x differentiation. Tan x differentiation is secant square x. Okay, plus again v into u dash. V into u dash. V is nothing but tan x and u dash means x dash. X derivative is 1. So therefore 1 is nothing but tan x only. So therefore f dash of x is equal to plus 1 here. For x tan x we are applying u into v method. Okay, so and plus 1 constant is equal to 0. So therefore f dash of x is equal to x secant square x, you can write x into 1 by cos square of x plus tan x. So therefore if you take that equation as equation number 2, now you have to substitute the values to get the first a and b value. So therefore start with 0. F of 0 is less than 0. F of 1 is also less than 0. F of 0 less than 0. F of 1 less than 0. F of 2 also less than 0. Next to f of 3. F of 3 you will get greater than 0. So therefore at f of 2, f of 3 you will get the opposite signs of the given equation. Okay, so then 2 and 3 will act as a comma b value. So therefore f of 2 less than 0 and f of 3 greater than 0. Then the required root lies between 2 and 3. The real root whatever we are going to find out the root, that root lies in between. Okay, lies in between the real line 2 and 3. So in between them it existed. So therefore now we are taking that initial approximation x naught. X naught is equal to a plus b by 2. So for this method also same, x naught is equal to 2 plus 3 by 2 is equal to 2.5. This initial approximation for the only iteration method changes. Okay, it varies for only iteration method only. In iteration method you have to assume the x naught value. In the previous lecture also we discussed that x naught is equal to 0.5 we assumed in the iteration method. For the regular falsy method, it is same. For the bisection method, x naught is equal to a plus b by 2, same. And now Newton Raphson method, it is also same. Only iteration method varies. You have to assume there. Okay. So by Newton Raphson method, for the formula for the ith approximation is given by, now we got x naught is equal to 2.5. This 2.5 is the in between 2 and 3. Okay. 2.5 exists in between 2 and 3. So therefore this is the general formula for the ith approximation, that is taken as equation number 3. Okay. So where I is equal to 0, 1, 2 up to so on. Now for I is equal to 0, take the first approximation. Okay. So therefore in equation number 3, if you substitute I is equal to 0, x 0 plus 1 is equal to x suffix 0 minus f of x naught by f dash of x naught. So therefore, since by initial approximation you got x naught is equal to 2.5, so therefore x1 is equal to 2.5 minus f of 2.5 by f dash of 2.5. Okay, since by equation number 1 and equation number 2. So here first of all you need to find out this value separately, and you have to find out this value separately. Then after finding the value separately, then substitute them in that equation. So here f of 2.5 is the x into tan x plus 1 is the given equation. Okay, that converted equation. Okay, after getting the simplification, we converted that equation x into tan x plus 1. So in place of there, you have to substitute x1 x naught value as 2.5. So therefore 2.5 into tan 2.5 plus 1. So you will get minus 0.8676. If you calculate it is with the help of scientific calculator, you will get minus 0.8676. Next value is f dash of this one. So therefore f dash of 2.5 is equal to 2.5 by, that means x by cos square x plus tan. So therefore 2.5 by cos square of 2.5 plus tan 2.5. So therefore you will get 3.1481. So substitute these two values in that above equation. Therefore x1 is equal to 2.5 minus of 0.8676 by 3.1481. So if you simplify that, you will get x1, the first approximation of the Newton Raphson method, is equal to 2.7756. Okay, this 2.7756 also exists in between 2 and 3. 2.5 is exactly between. Okay, 2.5 is exactly between of those 2 and 3. So okay, so 2.5 exists to exact the middle point of the 2 and 3. Now here we got 2.7. 2.7 means here it exists here 2.77. Okay, 2.7756. Now second approximation. So for I is equal to 1 in equation number 3, you will get x 1 plus 1 is equal to x1 minus f of x1 by f dash of x1. So first of all x2 is equal to, substitute those values and separate this value, find that value separately and find this value separately. You will get minus 0.0638 and this differentiation value 2.8. Substitute them in this equation, then you will get the second approximation. X suffix 2 is equal to 27984. Okay, 27984 means this is nearby that value only, this value 2.7984, very near. Okay, so therefore that is the second approximation. Next, third approximation for I is equal to 2 in equation number 3, you will get this equation. Substitute that x2 value and simplify f of x2 and f dash of x2. You will get x3 value, that x3 is equal to 2.7984. 2.7984. Previously x2 also we got same value 2.7984. Okay, so you can also cross check that value, x2 value 2.7984. Now here we got x3 value 2.7984. So by while solving these approximations, you have to realize that whenever you get a two consecutive approximation values are same, then you have to stop the approximation process only. Okay, no need to go to, if you do the fourth approximation, again you will get that 2.7984 only. Okay, so therefore by second and third approximations, x2 and x3 is equal to 2.7984. Therefore, the root of the equation is 2.7984. So, with the help of the Newton Raphson method, we conclude that the solution of this equation is 2.7984. Okay. So, this is the total explanation of this method. Okay. So, I hope you understood this problem very well. In the next lecture, we are coming with another interesting topic. Prepare well, make a perfect practice. Until bye. Thank you.